We will create fully procedural text animation, set up lighting and materials. I'll try my best to explain every single step of this process. Even if you have never worked with geometry nodes before, in this tutorial I'll show you how to control their power with your fingertips. To simplify the work with nodes, I use the Node Wrangler add-on. It can be activated in the settings. You can see the keys that I press in this area of the screen. Blender has a built-in text object, but it is not a mesh, so the possibilities of working with it are limited. The process of converting text object to mesh is an example of destructive modeling. After this transformation, you will not be able to make any changes available for a text object. For example, you will not be able to change text, font, character spacing, and so on. The advantage of using geometry nodes is that in fact we create a template and therefore can easily make changes in the future. Once you need to do more, then always do less. Moreover, using input node, you can change all parameters in one place. Let's start by renaming the cube to text. Let's add geometry nodes and rename them. By default, we have input and output nodes. We won't need the original geometry of the object, so we will separate these nodes. Now let's add a node that converts the string to a curve and connect the string to the input node so that we can change the text outside of the node tree in the panel on the right. I do the same with the size, character spacing and word spacing parameters. You can load any font. I use Montserrat Black. The text is center aligned. Right now we have XY orientation, but I prefer to work in XZ orientation. So I rotate the text. This can be done using the transform node. Now let's fill the letters with a triangulated mesh. To make the letters three-dimensional, add an extrude mesh node. Offset scale I also connect to input node and set the value to 0.15. Now the other side is empty. To fix this, we need to connect the resulting geometry with the original mesh. To do this, let's add a join geometry node. However, there are still two separate objects. If we make some manipulations with the mesh, it becomes clearly visible. For example, if we add a subdivision surface, you can see that the backside of the letter remains completely flat. To fix this, we need to merge corresponding vertices of these geometries together. Let's do this with merge by distance node, and nothing happens. Why? If we look in the spreadsheet window where the information about our objects is located, we will see that we have no vertices, no edges, no faces. That is, there is no mesh itself. Instead, we have instances. To convert them to mesh, we need to use the realize instance node. Something is still wrong. Let's switch to normals orientation. You can see that normals of the back wall are directed inwards, which corresponds to the initial orientation of the original geometry. To fix this, let's add flip faces node. Yay! The subdivision surface node was used only for demonstration, so we don't need it. Let's add material and connect this node to the input node. Let's choose the material. Now if we apply shade smooth, we get something strange. Let's add this node right here and select only the sides. This part can be considered as universal for working with text using geometry nodes. Therefore, it would make sense to combine these nodes into a group so that later they can be reused by loading them into other projects. You have to press Tab button to return to our main node tree. Let's name this group text. Now we can open a new project, add geometry nodes, Using the append function, we can attach the previously created node group to this project. Now we can select this node group from the list of all nodes. Let's return to our project. Now we have to create linear text array. We do this on the basis of a mesh line. Using the instance on points node, the vertices of the mesh converts into points where instances of the text object will be placed. For our animation, the offset should be along y-axis. First, let's add a combine XYZ node and connect the output of the offset scale, which determines the width of the letter, to the input of the y-axis. To control the distance between text elements, let's add math node, in which we select the add operation. Let's set the value to 0 by default, and then connect this field to the input node and rename this parameter as offset. Now we can control this parameter in the panel on the right. The number of elements we can change in the count field, move it up and set the value to 20. Let's set the gradual rotation of text instances. It is important to remember that we define rotation angle not in degrees but in radians. Since the rotation should be only along the y-axis, we use the combine XYZ node again. We also need an ID node containing information about the index for each instance of the object. In fact, to set a gradual rotation, we just need to convert indexes into radians. We do this using math node, where we choose convert to radians, and then scale this offset using multiply node. Now let's move on to the animation. To do this, we need a pinch of trigonometric magic. The main thing is not to be afraid of formulas, as they are just a set of symbols which unique combination makes a miracle. Do you know what else is important? Like this video! Moreover, you can send donation. This helps me make more educational videos. Links are in description. To undulate the size of text instances, we will use the cosine function. Let's think what is the argument of this function. We want the size of each instance to change sequentially over time. To begin with, we can create a wave-like distribution of objects in size. This distribution we determine by the cosine function. Then we can just shift this periodic function over time. Thus, the function argument consists of two parts. The first part defines spatial size distribution. The second part defines time shift. We control the size of objects using the scale field. I don't want to resize text along y-axis to keep shadows, so we can use combine node. Set the default value to 1. Let's add cosine node. Since it changes from -1 to 1 and our text size will change from 0 to 1, we remap the cosine value using the map range node and connect the result to x and z. Earlier we determined rotation angle for each instance according to its index. Now we need to do the same thing to scale instances. Therefore, we can use the same approach. Duplicate the multiply node. By changing this parameter, we can influence the period of our function. Now let's determine the time shift. We need a scene time node. Using the map range node, I convert the time value to radians. Here I indicate the numbers of the first and last frames. In the remaining fields, I specify values in radians. To loop the animation, the difference between the minimum and maximum values have to be a multiple of 2 pi. Also, I set the frame rate to 60 to obtain smooth animation. Now we have to set up lighting and materials. Let's add camera, move it a bit along y-axis. Now add a point light, change power to 30 and radius to 2. Move. Also add area light, change its shape to a rectangle, move it, rotate, increase the power, make it a little narrower, and narrow down the propagation angle to concentrate the light on the first text element. I also add depth of field in the camera settings, choose our text and defocus. Now let's set up materials. To add more depth, I use ambient occlusion. To control the strength of this effect, I add an RGB mix node. Let's set the value to 0.8. Here you can choose any colors you want. Also, for more contrast, I increase the metallic value. As a final touch, let's add a bevel. Often objects with a bevel looks better because it gives them a natural look. As in real world, not a lot of objects has a clear cut. Of course, text not an object from the reality, but in this case I like the result with a bevel more. Thanks to your support, I will be able to make more educational videos, so send donation and like this video. Bye bye!